The story of invention technology to produce super strong materials with high mechanical strength. The discovery of high-strength materials with exceptional mechanical properties has been a game-changer in many industries. In this article, we will explore the story behind the development of these super-strong materials. The history of high-strength materials dates back to the early 20th century, when researchers began to explore the properties of new materials such as alloys and composites. However, it wasn't until the 1970s and 80s that significant advances were made in the development of high-strength materials with exceptional mechanical properties. One of the key pioneers in the development of high-strength materials was John W. Kahn, who helped to develop a new class of materials known as bulk metallic glasses, BMGS. BMGS are a type of metal alloy that has an amorphous, glass-like structure rather than the crystalline structure of conventional metals. BMGS have several advantages over conventional metals, including exceptional strength, high elasticity, and good corrosion resistance. They can also be molded into complex shapes using processes such as injection molding, which makes them ideal for use in a wide range of applications. Over the years, researchers have continued to refine and improve the properties of high-strength materials such as BMGS. Today, there are several different types of high-strength materials, including carbon fiber composites, ceramic composites, and nanocrystalline metals. One of the key challenges associated with the development of high-strength materials is ensuring their manufacturing and production. The production of high-strength materials requires specialized processing techniques and equipment, which can be expensive and time-consuming. However, advances in manufacturing technology have helped to reduce these costs and make high-strength materials more widely available. The applications of high-strength materials are widespread and diverse. They are used in the aerospace industry to make lightweight, high-performance components, as well as in the automotive industry to make stronger and more efficient vehicles. High-strength materials are also used in medical devices, sports equipment, and even in construction materials such as concrete and steel. The development of high-strength materials has also brought about significant environmental benefits. High-strength materials are often lighter and more durable than conventional materials, which can help to reduce the environmental impact of manufacturing and transportation. For example, the use of high-strength materials in the automotive industry has led to the development of lighter and more fuel-efficient vehicles, which can help to reduce greenhouse gas emissions and improve air quality. In addition, the use of high-strength materials in construction can lead to more durable and long-lasting infrastructure, reducing the need for frequent repairs and replacements. This can help to reduce waste and conserve resources over the long term. The development of high-strength materials has also been a significant driver of innovation in the manufacturing industry. The production of high-strength materials requires advanced processing techniques and equipment, which has led to the development of new manufacturing technologies and processes. These advances have helped to improve the efficiency and productivity of manufacturing, leading to cost savings and increased competitiveness for companies that adopt these technologies. However, the development of high-strength materials also presents challenges and risks. For example, the production of high-strength materials can be energy-intensive and require the use of hazardous chemicals. It is important for manufacturers to adopt responsible and sustainable production practices to minimize these risks and ensure the safe and environmentally responsible use of these materials. The development of high-strength materials has also opened up new possibilities for the design and engineering of complex structures and systems.